Here we have a typical LPG installation of a residential customer with two 45 kg cylinders installed. The componentry that you would see on a residential installation is exactly the same as this, apart from the two gauges that you see on the cylinders. So we have an auto changeover regulator. Currently it's pointing to this cylinder, and this cylinder is the one that would be in service, and this cylinder would be the one that's in reserve. On here too we have the pigtails coming round, feeding into the regulator, and off the regulator we have the isolation valve and the condensate trap. And then from that installation your pipe work would go away to the gas installation, whether it be an infinity, a heating system or whatever. But this is exactly what you would see on the installation. So just a little bit on the regulator, this here, is that I've cut it into sections so you can actually see how it works. So basically the arrow indicates which cylinder it's going to point to, so it becomes the actually primary cylinder, the working cylinder. And basically all it does is just pushes extra pressure onto a cam inside the regulator, and that cam just chooses which side of the regulator it's going to let gas pass through. So once we've chosen that, it passes through the first stage of the regulator, and then it then comes through on the second stage of the regulator out to the installation. And there's the regulator diaphragm and spring for the second stage regulator. And that's controlled at 2.75 kPa. So we're just going to put the heater on, and this cylinder is the one that's in service. So you can actually see the vaporization of the actual LPG. So with the vaporization, an example of how that actually works is that if you imagine this is a jug at home with a glass and you put electricity onto it, so you heat the water and it gets to a boiling point and it evaporates into steam. LPG is a mixed product in New Zealand of butane and propane, and the boiling point of butane is 0 degrees and the boiling point of propane is minus 42 degrees. So any temperature in this room, which is probably about 18 degrees at the moment, is above those boiling points, so it allows the actual LPG to boil and vaporize. And it's all about the surface area as well. So the heat that's on this surface area, which is just the heat in this room, allows that vaporization effect to take place. Inside the cylinders is roughly just under 400 kPa of pressure. That's equivalent to what you would find in the natural gas system in the mains, so around about 400 kPa. And that's relative to the temperature on the glass cylinders. So the more temperature on these cylinders, the more pressure you would get. So if you imagine in the South Island when it's quite cold in the winter time, there is a tendency for the butane not to vaporize as much as the propane, but once the temperature comes up in the daytime, it will vaporize off then. In the North Island, when you've got warmer temperatures, there's not really an issue with any of the vaporization of both products. So if we had a bigger cylinder, a 45 kg cylinder, you would get a bigger surface area and a more area for the heat to get onto and to vaporize the LPG off it. So this pressure is in the cylinders now, and that's static. As soon as you start to use LPG, you start losing that pressure. So your installation is always on a decline of pressure. And that's why we have two cylinders, so one can feed the installation and the other one is ready for when this cylinder runs out, and it's an automatic changeover that occurs. Any installations that are where the demand is more than one cylinder, then you have to consider where you need two cylinders, so two this side, two that side, or you may want three this side, three that side, four this side, four that side. So you build your installation to actually suit the demand of the appliances that are being installed. So just put the heater back on again, and straight away once the vaporization starts, we start to see a decline in pressure. So as you'll see now, we're actually dropped pressure from 400 kPa down to about 200 kPa, and this will continuously drop whilst we have a heat source and using the LPG. For maximum demand, the LPG needs to be able to support that demand by having enough pressure in the cylinder. And you'll see as we go further down in the cylinder, the pressure will decrease. At approximately 112 kPa, the regulator changes over to red, which you can see has happened now. And that's the indication for the customer to then order another cylinder, because basically this one is, the in-service cylinder is now empty. The changeover occurs at pressure rather than the amount of LPG that's left in the cylinder. So we've still got quite a bit of LPG in this cylinder, but because of the temperature and the surroundings, we've already reached our pressure threshold as where the actual regulator will change over. So what you'll find is now, this cylinder is now the one that's feeding the installation, and the vaporization will occur off this cylinder as well. This cylinder will continue to vaporize and bubble, and as it's been going all the time, until this reaches around about 95 kPa. And then once it's reached 95 kPa, the regulator will not allow gas to feed through this side of the actual installation any longer. And then it feeds off this side of the installation totally. And the vaporization started there. We're down to at least 95 kPa on the gauge. So the system has changed over now, and then the customer would go ahead and order that cylinder. So you can imagine when the LPG cylinder delivery driver comes along, this cylinder is empty. The regulator is pointing to this cylinder. So this cylinder would be changed and the new cylinder would be put on a full one, and the indication would be changed over onto this cylinder, which has been the reserve, which is now the actual primary cylinder and feeding the installation. And what would happen again is the installation would just use up all of that gas. Customer would have a full bottle on this side, and then it would just be a change of process again. So then when that one would empty, it would be a vice versa, changing over of the cylinders. One thing that we never ask the customers to do is to alter this or turn a cylinder off, because basically you can imagine if the customer comes out and says, oh, it's red, I need to order another cylinder, so I'll turn it onto this one because I know that's full. And the driver comes along and sees it pointing to that cylinder, and in a day a driver could deliver up to around about 2.5 tonne of LPG in 45 kg cylinders. So if this was at the end of the day, when he's changing these cylinders over, this one could weigh just as much as this one after you've lifted those all day long. And basically he would exchange that one, which is practically a full cylinder, and then he would turn it back to this one, which is recovered slightly but not enough to feed the installation, and the customer would be confused as to which cylinder is which. So that's one thing we don't ask the customers to do. When you do your installation, you actually leave it with the instruction with the customer not to touch the regulator indicator and not to touch any of the cylinder valves. So we'll just flick that back onto there now. And that's how the installation would be left and continue to feed to the customer. So ongoing supply of LPG, if it's installed correctly with the right amount of LPG in the cylinders, the right amount of cylinders to feed the installation, and the customer knowledge of how the cylinders and the regulator works, then really your customers shouldn't have any problems in using LPG.